computer. You won't be able to see the slides though. I don't think.
No problem.
Or maybe I can share a screen. So then you can see the slides together.
Yeah.
Yeah, that's a big deal. Okay, that's probably a good idea. Yep. Yeah, I think that would be recorded. I just need to make sure I'm here so you can see my face and hear my voice.
Our team don't have lunch. So we had the first of the here.
I see. But will you be able to have lunch afterwards?
So we have time for this.
We have a team lunch today, so I think they will join once they finish.
Sure.
Send a message in the Wuhan group chat. Maybe anyone interested can join us.
Sure. I don't mind. It's recorded. People can see the recording if they want to, or they can ask people who joined it.
Yeah.
It's basic stuff. It's not very, very deep stuff. It's not something that you probably won't know. It's actually likely something that you already know. So this is just to make it explicit. These are the things that I found. In fact, this presentation is 5 years old, 5, 6 years old. I did that, you can see, in Atlanta when I was in the US. So that would be 2012. I wasn't very experienced at that time, but even then it was like, even people who are junior, they can probably sense some of the code smells. So it doesn't have to be someone super experienced to see CodeSmell. If you see some of this, and maybe you have more as well, and I'm happy to open up discussion and say, hey, you forgot about that. Hey, you forgot about this. That's fine. All right. So depends on who you ask. CodeSmell could just be a symptom. Means you might make a technical decision and you might make a conscious decision and say, actually, we want to code it this way. It might not look pretty, but there's a reason behind it. So CodeSmell can be just a symptom. It tells you there's something that's not necessarily good. It could be, instead of a symptom, an actual problem. So either a symptom of a problem or an actual problem. If it's a problem, then maybe you need to fix it. So if it's an anti-pattern, things that you really don't want in your code, then you need to fix it. So it really depends on who you ask. And that's, at least at that time, I think about, yeah, maybe there's two definitions depending on how strong the CodeSmell is. So Ward Cunningham is the person, he used to be a thought worker, is a very famous person. He's the one who came up with Wiki, the format, and eventually it's used as WikiLeaks and Wikipedia. But Ward Cunningham come up with this definition. A hint of possible bad practice to pragmatists, but a sure sign of bad practice to a purist. A pragmatist would be like someone who's practical. It's like, yeah, maybe it's okay, maybe it's not, depending on whether or not it's important. A purist would be, no, this is the way we do it. So very religious, very, very strong, say, this is how we do it. We're, as consultants in the real world, sometimes we need to make priority, sometimes we need to make a decision. So when you see a CodeSmell, it really depends on how bad it is, and then you can make a decision on whether or not you want to improve it. Ultimately, CodeSmell is really about code quality. All right, let's start with CodeSmell that's really maybe a symptom. So symptoms are, maybe it gives you an information about underlying issues. Maybe the underlying issues are the practices within the team, the lack of understanding. It's not a proof. It doesn't tell you that, yes, this is a problem. It's just a symptom. And it's not the laws of the universe. Once you see this, doesn't mean that you have to fix it immediately. It just tells you that there's something maybe wrong. As with real world smell, context is everything. If you see a smoke, doesn't mean there's a fire. Like at barbecue, smoke will be okay. But if at home you're sleeping and there's smoke, you probably need to be a bit worried. All right, comments. Comments I consider like a symptom of an issue. So these are a couple of problems when you have comments. Comments that describe, so inside your code, you have comments. The problem is sometimes it's misleading, especially if you don't update the comments along with the code, because there's nothing that forces you to update the comments along with the code. Sometimes what we encourage people is if you really, really want to put comments, put it into the git commit comment. It doesn't have to be the top line. It could be like the second line, because it gets updated with the code and it's together with a change. So when you look at the change, you git blame the change. You can look at the git commit that creates the change, and then you can look at the git comment. If you see the comment along with the code, sometimes you can't guarantee which one is correct. A comment could also be redundant, which means it actually just tells you what the code is doing, in which case it's like a duplication. So if it's misleading, it might be not true. If it's not true, let's say the comment says something, the code says something. If you're a developer, you come in and then you read it, it's like, so which one do I trust? Do I trust the comment or do I trust the code? It's confusing. Comment is very frequently not noticed by developers. If you use an IDE, sometimes you can change the color scheme and the comment becomes really gray. So you don't get encouraged to read it. So you just skip it and you don't really care about it. The exception will be like Java docs. Java docs you can actually read when you do IntelliSense. So it really depends. But if you have like inline comments, usually it's a bad idea. I mentioned the ability to drift, because typically developer come in and then they modify the code, they don't modify the comments. So that means the comment and the code becomes more and more separate in terms of what it's trying to say, and it's cluttered. If you don't have the IDE that helps you to close the comment, it's just when you read it, there's comment, code, comment, code, comment, code, and it becomes difficult to read. This is a typical smell. When you have a comment that just describes what the code is doing. The code should be the what. It really should tell you the what and the how. When the what is clear, comments are redundant at best, or possibly incorrect, confusing, or misleading. So redundant just means, okay, this is just additional duplicated information. But if it's not duplicated information, it could actually be misleading. It could actually give incorrect understanding. When the what isn't clear, so if you write a code and then the code is difficult to read, don't add a comment. Focus on trying to make the code more readable instead of adding a comment. A comment is like a shortcut. Don't do that shortcut, because there's other cost of adding the comment and maintaining the comment. So in my university days, my college professor, computer science professor, my programmer tutor, they tell everyone that they need to put comments everywhere. They said, no, your code needs to have comments, comments, comments. In the real world, that's actually a bad idea. Focus on clarifying the code. Don't listen to the college professor. They want comments because they're lazy. They want to read the comments, doesn't really want to read the code. Most of the time, people who begin to program, they write really, really shitty code, and they don't actually try to make people to code better. They're just trying to get people to be able to solve the solution and to put the comments so they can read the comments. That's not true for real world, because when we want to maintain code, we're not maintaining comments, we're maintaining the code. And we want the people to be able to read the code. So eventually, because of that habit, they're going to say int x equals to 5, and then they put set x equals to 5, which is obviously very, very redundant. It just describes what the code is. If you think a reasonably capable person in Java or in JavaScript in your code, if a reasonably capable person will be able to understand this code without a comment, then probably the comment is not necessary. Like if you're a Java programmer, you see this code, and then you say, actually a new Java programmer, when they look at the code, I think they know what this is doing. And this is absolutely not necessary, right? The next code smell is long methods. Why are they smelly? So when you have a long method, so one function, actually it's one of the metrics. There's a research done. It's not recent research as well. It's actually quite an old research. If a function doesn't fit into a screen, if a function goes beyond like 80 lines, then the likelihood of bugs inside that function increases. I think there's a research on that, and then that's why people encourage to actually do abstraction and try to reduce the length of the function. Why is it a problem? Why is it smelly? Because when the function is larger, quite often there's duplication inside the function. Quite often there's just code duplicated over and over again, trying to do the same thing. And because you don't abstract it, it's just doing the same thing over and over again. The other thing why this is a smell is maybe it has too many responsibilities. It's taking multiple concerns. And what's the problem with having multiple concerns? The first S in solid, single responsibility principle. Why is it important? Because if you have multiple concerns, that means there's multiple reasons of change. Why is it a problem if there's multiple reasons of change? That means if you have a team and then you have people working on different stories, those two people working on different concerns, they might need to touch the same function because this function might actually be handling both of those concerns. That means you're going to step on each other's toes. That means trying to do development and isolated development is getting more and more difficult. Multiple concerns is also more difficult to maintain. The test is going to be bigger and it's just going to be a lot difficult more to test as well. So it's usually harder to test. It's usually harder to maintain because you need to understand the whole function before you make any changes. It's also it's also harder to digest, to understand, to read. How long is too long? Focus on the number of concerns instead of the number of lines. So yes, I mentioned the number of lines, that's one metric, but really if you want to think about a function, think about its responsibility. So you want to reduce the number of responsibility in the function, not really just the number of lines. Let's say you have a long function and you said, oh, I just put everything in one line. Yes, of course, you have a one-line function, but then you still have the 5 responsibilities inside the function. So that's not going to help. One of the strategy, if you extract the separate concerns into individual smaller methods, you can actually have like smaller methods to do that. Tests would be easier to write. Tests would be easier to understand. Code would be easier to maintain. Next is message chain. And I want to highlight this in the context of Lombok or fluent interface. This is different from a fluent interface. It looks the same, but it's actually 2 different things. Mary.getFriends.elementBob.save. So if you have used Lombok before, it actually looks like that. Fluent interface, you just dot, and then, but usually when you use Lombok for a builder interface. You put an annotation at builder, it immediately creates a builder for you, and you don't have to write and maintain code for that. Fluent interface is, itself, if you don't use a framework like Lombok, if you don't use it for a builder, I would highly suggest to think twice before introducing a fluent interface in that scenario. Fluent interface is really good for builder and for things that somebody already provided for you, but if you create one yourself, it's just a nightmare to maintain. So if you can, don't add any more fluent interface, even though it's really, really easy to use, because maintaining the library is really difficult. That's why if there's a framework for it, just use it. In this case, it's not about fluent interface because usually fluent interface just returns the same thing over and over again. This one, not necessarily returning the same thing. Mary is an object. GetFriends returns you a different object. At element will be the responsibility of friends, not the responsibility of Mary. And save will be not the responsibility of Mary and not this responsibility for GetFriends as well. It might be like an entirely different object that you get at the end. So what happens is GetFriends is one object, sorry, Mary is one object, GetFriends is another object. At element might give you a third object. You're now already coupling these 3 objects together because you do this message chain, you dot, dot, dot. Every time you do a dot, essentially you're creating a coupling between those 2 elements, especially if you're returning a different element. What is an, if you just read the code, you will ask, what is an element? Why do I care about an element? And then you read this, save. Why do I care about save, right? So you might think, okay, let's say it's not in one line. Let's say I just separate it into different lines. So friends equals to Mary.getFriends, friends.addElementBob, friends.save, for example. Let's say you do that. Do I fix the problem? So because in one line, I have multiple, I don't only have 1 dot. No, you're not fixing the problem. because the concerns inside this 3 lines is the same multiple concerns, right? Same question. What is an element? Safe, even if it's only 1 dot. Between those two, it's just equally bad. It's the same degree of coupling. It's about the degree of coupling. It's not about the number of dots. Even though it gives you a indication, yes, the number of dots gives you an indication, but really it's about the degree of coupling. There's this thing called the law of the meter. The law of the meter tells only talk to your closest friends. So essentially just have 1 dot on everything. Only talk to the objects that's passed to you or the objects that you have access to. Any method of an object, you only call methods belonging to itself. So you have a class, you can only call method that is in that class. You can call any method that belongs to the parameter that's passed into the method. You can call any method for any object that it creates itself and any composite objects. There's a quote there. When one wants to walk a dog, one would not command the dog's leg to walk directly. Instead, one commands the dog, which then commands its own leg. If you have a dog, you don't force the leg of the dog itch to go by its own. You just walk the dog, and then the dog knows how to walk itself, right? Your responsibility is to the dog's responsibility is to its legs. So there's this thing called tell, don't ask. There's a principle. You tell the other object on what needs to be done instead of asking. Asking means you actually need to have the responsibility on yourself. Asking, right? You're asking different things. If you tell, you get the responsibility on them. So instead of mary.getFriends.addElementBob save, you just say mary.addFriendsBob, and then you just take care of it there. So the next code smell is primitive obsession. And I think I mentioned this to you before about maybe there's some primitive obsession in the code. Primitive obsession is when you try to use primitive types for everything to represent everything. So you use int for everything. You use string for everything. And the reason why it's a smell is because whenever you use int or string for everything, you now need to do a lot of translation when you need to perform quite a lot of operations. In fact, one of the enterprise pattern that Martin Fowler introduced in his book, Patterns of Enterprise Application Architecture. One of the enterprise pattern is a money object. Explicitly, he said, like, money object is an enterprise pattern. It's actually a good idea to introduce a new object called money, because in a business sense, it's actually very, very useful. Whether you want to add money, you want to add interest, you want to actually translate the money to something else, whatever, money is very useful. That's actually true for a lot of things. And one of the common example will be time or date time. If you keep on representing time as string over and over again, what if you want to add an hour to it? Then you actually either you have your own logic to add an hour to the time, or you need to convert it into a time object, add 1 hour, and convert it back to string, which is extra operations that you don't really need, right? It also couples a couple of things, right? The string is really a representation of time, not time itself. So time has a lot of responsibility, like add time, add hour, and whatever. And then in order for you to have access to that responsibility, you have to convert it there. And then the string is really just a representation. If you think about string as a representation, it also means that if you ever need a different format of time, it's not your responsibility to do that. You can get the time object or the date object to do that for you. So current time is stringly type. What if we want to know the minute? That means we need to parse it ourselves or create the time object and get the minute out. What if we need to format the time differently? Like I said, you need to create a time object and then create a new format. What if we want to add 20 seconds? Again, you need to think about how that logic gets implemented. It's smelly because it is a misrepresentation of an aspect of the domain. Misrepresentation. String is just a view of time. And if you use it, if you keep the view of a time, it's not really the time itself. Suggest mixing separate concerns, the concept of time and the human readable concept of time. The time itself, I kept on mentioning there's so many responsibilities to time, but you kept on storing just a representation of it. So it places a greater burden on consumers of the value. And you'll find that whenever you need to do operations on the time, you feel that burden because I need to add 2 more lines in order for me to solve the problem. So considering modeling the concept with a class, this is how you might want to take care of it. So you reduce the burden on the consumer. So once you get the consumer asks for time, you give it a time object. And then the consumer said, oh, good, I got a time object. I can pretty much do whatever I want with it because all the concern around the time is already encapsulated into the time object. Association of related behavior as class methods. Yes, time has all the responsibility that it needs. Facilitates self-documentation of code. The value and its associated behavior will be exposed through the public interface. If you encapsulate time with all behavior there, then if you want to inspect this, you can just say, okay, what's all the public interfaces that it has? It becomes a self-documenting code. All right, this is just some Ruby example there. Time.new, hour, minute, second, and then instead of that, you just create, and so if you ask for time, it just gives you a time object. All right, let's move on. We talk about symptoms, like maybe you want to fix it, maybe you don't, depending on the situation. These are stenches. In my opinion, it's much stronger smell. That if you find it, try to fix it because this is really bad. This is anti-patterns. Code stench, unbearable smell, ruins the rest of the atmosphere. There's a difference between something doesn't smell right and someone farted in the room. If someone farted in the room, it smells really bad and say that really smells. It's just ruins the whole atmosphere. Right. So I use this as a commandment. These are the things like you should not, right? You should not comment a code and check it in. I hope nobody does this. If somebody does this, it's something that you probably want to talk to the other person and say, I don't think it's a good idea for you to comment code and check it in. We have Git. That's pretty much the reason why we have Git. If you need to have history, just delete it, and then you can always go back, right? Don't comment code and check it in. You should not leave dead code and be cool with it, right? Let's say you have a couple of functions and then you're using, okay, this method. At one point, you're saying, we don't need that. We don't need to call that function anymore. So now you have a function that's never been called. In Java, hopefully it will be easier because it tells you that a function is never called and therefore you can just delete it. But in some other language, it's not as easy. But if, for example, there's no tool that help you, it's something that you want to think about. Don't have that code lying around. Similarly, hopefully you have like JS hint or style cop or sonar that tells you, for example, if you return on top of the function and then the rest of the function are never called, then get rid of it, right? Hopefully you have static code checking that helps you to do that. A lot of this, when I started, there's not a lot of tools that does this for you. And therefore I need to explicitly tell you, hey, this is a bad idea. You should not write code for speculated feature. So there's a term called YACNI. You ain't gonna need it. You are not going to need it. This is true when you're writing a story and then you don't know what the future story is coming. And then you said, let me try to design it in such a way that maybe if there's a new story coming in, then we can do it better. The decision to do that really depends on whether or not you're going to add complexity. If you are going to add a lot of complexity, that means you're going to have additional costs to maintain the code. If you're not going to add a lot more complexity, let's say, then yeah, it's okay. It's okay to design it so you can maintain it. It's okay to design it so you can extend it. It just depends on whether or not you add more complexity. If you guess features and you add so much complexity to make it a lot more extendable, then probably it's not worth it. For people who have paired with me, I kept on telling people that I have the rule of 3. That's usually the right time to start designing. So for things that's duplicated, when I write code, the first time I done it, I'll try to do it the simplest way possible. The next time I do it, I try to, if I need to duplicate it, I'll just duplicate the code. It's fine, trying to do the simplest thing possible. The third time I do it, it's definitely worth the effort to actually refactor. So if I see duplication, the third time I do it, the third duplication, that's the right time for me to refactor. Usually, that's my rule of thumb. It could be different for all of you as well. You should not abstract speculatively. If, for example, you have a code and then you say, I think there's too much low-level detail implementation right here. So I'm just gonna abstract it. I'm just gonna put it into a different function. But then the difference between the previous code and the next code is just one line of code. It's like, okay, it's delicious, and then it just returns true. That just gives another extra 5 seconds, 10 seconds for a person to be able to understand your code instead of just looking at this and then putting it here. It makes it difficult. So earlier in my career, because I don't do object-oriented programming, earlier in my career, one of my pet peeves, one of the things that I really hate is if someone introduces an interface for one method. I am super pissed off for that. Not only someone introduces an interface for one method, but also someone introduces an interface for one method and one implementation. It's just like, why do you do this? When you want to introduce an interface, you need to understand why you're introducing the interface instead of like, oh, interface is a good idea. That's why I'm just going to introduce a million interface. And then what ends up happening is you have one interface, one class, and there's no other implementation. I question that. I would ask, why do you do that? I know interface is a good idea with regards to understanding what needs to be done there, but encapsulation already does that. If you have a class with a public method, and then that already exposes what the other consumer is going to need, and you don't need the interface for any other implementation, you don't introduce it there. You introduce it when you have a purpose to introduce the interface. So that's why I'm a little bit annoyed when someone does that. You should not sacrifice cleanliness and readability for performance. So in this case, public cook dish var ts equals to new array alias thread for each I in dish ingredient thread equals to new thread start t start t add for each var t and ts t join. What is the code doing? It's doing something. You actually need to go to the thread code to actually understand what it's doing. But this cooking dish, it's actually not going to tell you anything. It just gives you the boilerplate to create a thread to be able to run this in parallel. For a developer that comes in, all information that he got in terms of cooking dish is the boilerplate on starting a thread. That's not an important information. Remember, for people who joined me in the unit test, I talk about the concept of SNR, signal to noise ratio. The signal is the important information. Everything else is noise. When you write a test, it's the same thing. You want to make sure that inside the test, you have the important information for the next developer to be able to read to understand your code. Same thing when you write a code. When you write a function or whatever, you want to have the important information in the code. I'm not saying trying to code for performance is bad. I'm saying there's usually a trade-off between having a performant code and a complicated code, especially if you want the code really, really fast. Sometimes you have to sacrifice readability. If you don't need it yet, don't do it. Especially if you haven't done the analysis on what's the bottleneck, what's actually slowing you down. Sometimes it's not your Java code or your Ruby code or whatever. Sometimes it's the SAP connection. Sometimes it's the database connection. If you don't look at it from an end-to-end perspective, you're optimizing something that's not going to give you the overall benefit. So what's the point? You're already paying the cost of actually writing performant code. You're also making future you and future team pay the cost of maintaining the code as well. So it's expensive, not just now, but also in the future. If you don't need to pay that cost now, don't do it. Think about whatever you're going to introduce, complexity is going to have costs. And if you are going to introduce something, make sure that it gives you the most benefit. Where is it going to give you the most benefit? In my experience, usually it's not in the code. Usually there's other bottlenecks. Try to solve that first. Next is refactor baiting. So this is refactoring for the sake of refactoring. Basically, you said, okay, let's refactor it this way. And then the next day, actually, we need to refactor it this way. So you just endless refactoring. I'm not saying endless refactoring is bad. I want you to be intentional when you do refactoring. You need to understand what is it that you want to gain, what is the output, have an understanding. It's going to have cost when you refactor. And then just make sure that you are actually going to get the benefit out of the cost that you're getting. Continuous refactoring is actually not bad in terms of continuous improvement. But if you refactor for the sake of refactoring and you have this never-ending refactoring, then it's actually going to be costly. And it doesn't give you the output and the benefit that you're going to get. All right. Code coverage could be a smell. This is not a stench in say, but your attitude, the way you see code coverage, the way you see code metrics could be a smell. So code metrics is good because it's objective measurement, in the sense you can't argue with an objective measurement, right? If it says, what is the coverage of your code? 95%. You don't argue and say, actually it's 96. No, the tool actually tells you it's 95%. It suggests, it only suggests, it just tells you an information. It suggests the health of the code base. It suggests the trends in the code base. That means last week it's 90%, this week's 95%. Oh, maybe we're improving. But if we say you need to have your code coverage 90%, or you need to have your code coverage 95%, usually it's meaningless. It's really the attitude against the number. And just because you have code coverage, just because you have static code analysis, it doesn't mean you can write bad code. You can still write bad code. It's not a crutch. It's not an excuse. It doesn't justify bad practices. It helps you. It helps you in maintaining good code, or just gives you information that you might not realize. But again, it's not the only metric that you need to care. It doesn't mean that it's going to substitute all your other practices. I know that some teams are doing code diffs, some teams are talking like about CodeSmells, refactoring as a group activity. Continue to do that. CodeSmell, code coverage metrics, sonar metrics, analytics is not going to substitute. It's supposed to complement. So those things could help you in getting a better code. And that's pretty much it. Do you have any questions? Cool. There's no question. This is a bit short compared to yesterday. Actually, it's about the same amount of time. It's 20, 30 minutes-ish. Like I said, it's not anything new. It's something that's likely that you know before. Hopefully, this gives you just a bit of a structure and like, okay, I never thought about that. Or yeah, I know about that. Now I have a vocabulary to actually use it. All right. For people who haven't had lunch, I'm sorry to take your lunch time. Hopefully that was useful. Thank you.
Thank you.